In this video, we shall solve the integral of e to the power of cos inverse of x dx. First of all, let's use u substitution. We shall set u to be equal to cos inverse of x. This means that cos of u will be equal to x. And if we differentiate this, the derivative of cos is negative sine. So this will be negative sine u du equaling to dx. And therefore, our integral will become the integral of e to the power. Now cos inverse of x will be u times dx, which is negative sine u du. And at this point, we can use integration by parts. We will let a to be equal to, let's say, the part that is easier to differentiate. This time, let's take negative sine u. If we differentiate this, dA will be equal to negative cos u du. And we shall let dv du to be equal to e to the power of u. And therefore dv is equal to e to the power of u times du. If we integrate both sides, on the left hand side we shall have v equaling to e to the power of u. Therefore, the integral of e to the power of u times negative sine u du will be equal to the formula we shall use, the formula of integration by parts. We shall have fv minus the integral of v times dA du and then times du. This will give us the integral of e to the power of u times negative sine u du equaling to a is negative sine u times v, which is e to the power of u. So this will be negative e to the power of u sine u and then minus the integral of v, which is e to the power of u times. Now from this we can get dA du. If we divide both sides by du, we shall remain with dA divided by du equaling to negative cos u. Therefore this will be multiplied by negative cos u and then du. Now once again, in order to solve this integral, we shall use integration by parts. As we did before, this time let's set theta to be equal to negative cos u. If we differentiate this, the theta du will be equal to negative sine u, which is positive sine u. And if we set dv du to be equal to e to the power of u, if we cross multiply, dv will be equal to e to the power of u times du. If we integrate both sides, we shall have v equaling to e to the power of u. Therefore, our integral will be equal to negative e to the power of u sine u minus, now this will be theta times v minus the integral of v times the theta du and then times du. So we shall have the integral of e to the power of u times negative sine u du equaling to negative e to the power of u sine u minus theta times v will be negative e to the power of u times cos u and then minus the integral of v, which is e to the power of u times the theta du, which is sine u and then times du. Now if we pull out the negative, we shall have negative integral of e to the power of u sine u du equaling to negative e to the power of u sine u. Now if we expand this, we shall have plus e to the power of u cos u and then plus the integral of e to the power of u sine u du. Now if we take this to the left hand side, we shall have negative 2 times the integral of e to the power of u sine u du equaling to negative e to the power of u sine u and then plus e to the power of u cos u. If we divide both sides by 2, we shall remain with negative integral of e to the power of u sine u du equaling to e to the power of u cos u minus e to the power of u sine u divided by 2. We can again express this as the integral of e to the power of u times negative sine u du equaling to e to the power of u cos u and then minus e to the power of u sine u divided by 2. Now if you remember, at the beginning we set u to be equal to cos inverse of x, and after we got cos u equaling to x, and when we differentiated this we got negative sine u du equaling to dx. This means that our integral will become the integral. Now this will be e to the power of cos inverse of x and then times, now negative sine u du will become dx. And you will realize that this is the integral we were told to find, and this will be equal to, now on the right hand side, what will we have? From this we have cos u equaling to x. If we draw a triangle, our angle is u, and cos u equaling to x is the same as cos u equaling to x divided by 1, and we know that cos is the same as adjacent over hypotenuse. Therefore adjacent will be x and the hypotenuse will be 1, and therefore the opposite will be 1 minus x to the power of 2. This means that from this we can find sine u. Sine u will be, sine is the same as opposite divided by hypotenuse. Therefore this will be square root of 1 minus x to the power of 2 divided by 1, which is the same as square root of 1 minus x to the power of 2. Therefore our integral will be equal to e to the power of cos inverse of x times cos u, which is x, and then minus e to the power of cos inverse of x times sine u, which is the square root of 1 minus x to the power of 2, and this will be divided by 2 plus c, and that's our answer. Therefore, that's how you can solve such an integral. If you have found this video helpful, don't forget to like it and also subscribe to my channel. Thank you for watching and have a nice day.